This project is about how the Magnus effect makes a baseball spin and how the drop on a bat affects how far the baseball goes when hit off it. When a baseball spins, it creates a cushion of air around it called the boundary layer. The interaction of the boundary layer and the air surrounding it results in an outside force that changes the path of the ball. This is called the Magnus effect. The Magnus effect is named after German scientist Heinrich Magnus. When a ball has a backspin or the pitcher throws a fastball, the boundary layer under the ball pushes air forward into the air that is trying to move around the ball. On top of the fastball, the boundary layer pushes air backwards in the same direction as the air that is trying to move around the ball. These air combinations create faster air movement and lower air pressure. The combination of slower air under the ball and faster air over the ball creates a lift called rise. This case of the Magnus effect acts like a wing. When the pitcher throws a curveball, the top spin is like the wing turning upside down. The opposing air flows are now on top of the baseball, and the complementary flows are on the bottom. This time the Magnus effect creates a lift that complements gravity, a drop. When the spin axis is tilted, the lift is tilted. A right tilt adds left to right movement when the pitch has backspin and right to left movement when the pitch has topspin. A left tilt is the opposite. When the pitcher throws a gyro ball, the Magnus effect is null, bearing crosswinds causing the ball to spin like a bullet. The ball moves counterclockwise for left-handed pitchers and clockwise for right-handed when viewed from the pitcher's perspective, and no part of the boundary layer goes against or complements the surrounding airflow. This type of spin results in a smaller wake behind the ball. A smaller wake means less air resistance, causing the gyro ball to reach home plate from the pitcher's mound faster than a fastball.
So to grip a fastball, you put two fingers on the seams like this, and when you throw it, you reach back and bring your arm over your head and let go. So to grip a curveball, you put two fingers together, right like this on the seams, and then when you throw it, you bring your arm over your head and curve your wrist, like flick your wrist down, and so the ball will curve when you release it. The gyro ball, it is gripped exactly the same as a fastball with two fingers on the seams, but not together like the curveball. And when you throw it, you bring your arm over your hand and flick your wrist the opposite way that you flick a curveball.
The drop on a bat is also referred to as weight drop. The bat with higher weight drop hits the ball farther. An example is a bat with -3 drop will hit the ball farther than a bat with -12 drop. Weight drop is calculated by subtracting the height in inches of the bat from the weight in ounces of the bat.
Not yet. When I hit with this bat, it has higher drop, so it went farther. When I hit with this bat, it has lower drop, so it didn't go as far.